Lesson 68 is going to cover surface area of cones, spheres, and pyramids. Surface area is basically a sum of all the areas of the faces added together. It's measured in square units. It is an area, so it has to be units squared. And then we'll find the surface area of the three given: cone, sphere, and pyramid. Basically, we'll walk you through on finding the surface area of a cone. First, notice that you are given a formula. That formula equals pi r squared plus pi rs. R represents the radius, S represents the slant height. Notice that the slant height is on the surface. It is not a height on the inside of the cone here. The height on the inside deals with volume. So you're using a slant height which is on the surface, hence surface area. In example 1, I always find it most beneficial to go ahead and write out my formula and then substitute in the values that I know. So the next step here, we have surface area equals pi in for r. R is the radius, which would be 6, and that is squared, plus pi r. Radius is 6, and the slant height that we're using is 13.4. Now go ahead and do your computation. We come up with 36 pi plus 80.4 pi, and our answer here says that we want to leave in terms of pi, so we're not doing any rounding here. So the next step is to go ahead and add these together. With 36 and 80.4, we find out that the surface area is equal to 116.4 pi, and this would be yards squared. So we have our answer in terms of pi. Basically what we didn't do is we didn't multiply pi into 36 or the 80.4, and we added those together, which essentially you'll multiply that pi into 116.4, giving you the answer. But we need to leave it in terms of pi. Why don't you go ahead and give example 2 a shot. The only difference is here it's listed off in words versus a picture. So let's go ahead and substitute in the values that you know into that formula. There's the surface area formula for a cone. Substitute in the values you know. There's our values after substitution. Now do some computation. Leaving with your answer in terms of pi, we have the surface area is equal to 29.1 pi, and we would need to label this feet squared, being an area. That will conclude example 2. Example 3 and 4, we're going to cover surface area of a sphere. Formula given is 4 pi r squared, again r representing radius. Starting off the problem using the formula given, use substitution here. So we have that the surface area equals 4 pi, and in for r being the radius, we're going to substitute in 6.8, and we need to square that. Do our computation here. Everything is being multiplied. Order of operations, I'd take care of 6.8 squared. I would multiply that by 4, and I would have my surface area in terms of pi, which would be 184.96 pi, because we didn't multiply by pi. We are going to leave in terms of pi for an exact answer. And then we would have inches squared being our label there for example 3. Example 4, start off with the equation. Use the substitution. We need to substitute in for our radius. We know that the diameter here is 14. So in for our radius, we should substitute in 7. Following our substitution, do our calculation here. And we have the surface area equals, well, we'll take care of your exponent here. 7 squared is 49. 49 times 4 would give us 196 times pi. And this label would be kilometers squared. So that would be the surface area of that sphere. The last component that we'll cover is the surface area of a rectangular pyramid. You may have a square pyramid. One thing that's nice about a square pyramid is that you have 5 faces, so you have your base. In a square pyramid, you'll have 4 triangular faces the same size. In a rectangular pyramid, you'll have 4 faces, but not all being the same side. 2 faces will be identical, so you have 2 pairs of identical faces. When I calculate the surface area of a pyramid, I like to go ahead and find the area of the base first. And the area of the base here is looking like we have a square pyramid because all sides are the same length. So to find the area of the base, to find the area of a square, you would take the side times side. In this case, it would be a 5 by 5 base, giving you 25 miles squared. There's the area of the base. Next, you need to find the area of all the faces, the triangular faces. Now, with a square pyramid, all the triangular faces will be the same size. So you have to find the area of all 4 triangular faces. Now, to find the area of the 4 triangular faces, we have 4 faces. So what I'm going to do is multiply by 4 right away. Next, I need to know how to find the area of a triangle. The area of a triangle, if you have forgotten, area of a triangle is 1/2 times base times height. So that triangle that we have here, I'll highlight in green. The base, well, 4 faces times 1/2 times the base, which is 5, and that height. That height has to be this slant height. That slant height is on the outside, is on the surface. So we would multiply by 7.4. Next, go ahead and do all your computation there, all that multiplication, and you would wind up with 74 miles squared. So we have 74 miles squared. Now, to figure out that total surface area, you need to take all the faces and add them together. Well, we have the base of 25. We have the 4 triangular faces of 74, which would give us 99 miles squared would be the total surface area of that square pyramid. As we dive into 6 here, you'll notice that in 6, we're no longer dealing with a square pyramid. We have a rectangular pyramid. So you'll have a couple different triangular faces, pairs of triangular faces here. Still start out by finding the area of the base. The base is a rectangle. So you have 5 by 2, giving you 10 inches squared for the base. The next, I'd like to go ahead and break down the triangular faces. So I'm going to say maybe this one right here, this larger one, will be the front. Well, that front face will be the same as the back. So normally what I do is list it off as front and back triangular faces here. When you're talking about a front and a back, you're covering 2 faces. So I have to multiply by 2. And we know to find the area of a triangle, it is 1/2 times the base. Well, the base of that front face is going to be 5 inches times the height, and that is the slant height on the surface, which would be 5.1. Do your computation, and we come up with 25.5 inches squared. Next, we're going to go ahead and take care of what I normally call is the left and the right faces. So the left and right face here, I'll outline this here in blue. We have this face right here, that triangular face, so left and right I call them. So when I do my calculation for the left and right, again you're talking about 2 faces, need to multiply by 2. The area of a triangle, again, is 1/2 times the base. The base of that blue face would be 2 by 5.6, and we come up with the surface area, or I should say the area of those faces would be 11.2 inches squared. To find out that total area, surface area, add them all together, so all 5 faces together, giving us a grand total here of 46.7 inches squared would be the surface area of this rectangular pyramid. Example 7, I'm going to go ahead and let you try to work through this one. Notice it does list things off in words. I always find it most beneficial is to draw a plain Jane simple sketch. So it says find the surface area of a rectangular pyramid measuring 3 centimeters and 7 centimeters long with the along the base. The slant height is 7.8 centimeters and 7.2 centimeters respectively. Now if you look above, notice in the rectangular pyramid that you did have 2 different slant heights. So those are the slant heights that you need to use in example 7. So start off by drawing a simple sketch. So I've started just drawing a simple sketch of my base here. It's 3 by 7. We know that a pyramid all comes to a point, so I like to go ahead and draw a point just above and then construct lines to that point. So I'll just draw a few of these to that point from each of the corners coming up. All those we can see, and then this last one would kind of be a hidden face that you wouldn't be able to see, so I usually draw those hidden faces as a dotted line. It also gives us 2 respective slant heights. Remember, slant heights are on the outside here. So I'm going to go ahead, I'll say that this will be the slant height of this triangle, and remember it'll come down and form that right angle there. And I'll just say that this one is 7.8 centimeters. The next one we have is maybe I'd call it the front face. Here's another slant height, forms that right angle, and this one was 7.2 centimeters. Now that I have those measurements, I could go ahead and figure out the surface area, just like you did in example 6. So why don't you pause it and try to work through it. Start by finding the area of the base. 3 by 7 giving us 21 centimeters squared. Next I'll take the front and the back triangle. Remember this is a rectangular, so you'll have faces of different measure. I went ahead and highlighted the front triangle, and I'll put out the dimensions there. Multiplied by 2 faces, times 1/2 times base is 7. Height is 7.2, giving us a total of 50.4 centimeters squared. So now I need to take care of the left and the right face. Highlighted that face in black. Multiplied by 2 faces, times 1/2, base being 3, slant height 7.8, giving us a grand total of 23.4 centimeters. Now we need to figure out the entire surface area. So I had to add all those surface areas together, and we would wind up with 94.8 centimeters squared. This will conclude lesson 68 on surface area of cones, spheres, and pyramids.